Hi everyone, welcome to my channel Stack and Soul. So in our previous video, we got familiar with the LangChain and Gemini by building a simple research assistant. So that video was our first hand example of how LangChain can connect multiple LLM calls into a structured workflow. So if you want to refer the concept, please go to my previous video in this series with the title Build Your First Gen AI Pipeline with LangChain and Gemini. So now in this step, we will shift gears and look at a different but very practical scenario using LangChain and Gemini with structured data. Now, instead of working with plain text, we will generate a small CSV-like dataset in Pandas and then query it with Gemini. So here also we will introduce the idea of token efficiency. So this video will just lay the foundation for what comes next, which is the rack pipelines, where we will work with external knowledge bases and embeddings. But let's start now with the walkthrough. So like execution starts here before any code runs, the dependencies and the keys are loaded, and we have loaded our free API key, and like we are setting up this. You can see we have just imported the API key from another notebook, and if this step fails, the program will crash later at model initialization step. So I'm repeating this like line again and again in all my videos. So the next step is basically the creation of sales data, the structured input. So this is a fake sales data set generated to mimic a CSV file with the columns product, sales, and region. So the data set is the raw material. Like this is the core raw material which we will later query with Gemini. Next is basically the summarization part. This is where we talked about token efficiency. So sending the full data set can consume unnecessary tokens. So what we are doing here, we are shrinking the input. So here you can see the n largest, right? And there is something called n smallest, which we will discuss again in some time from now. So the first, this n largest is keeping only the top five rows, and alternate n smallest could show the bottom five. So what it does actually, so both these lines, like whatever you select depending on the use case, right? So only the reduced data set, which is like here, whatever, whether you select the top five or bottom five, that is coming into a variable summary data that goes to Gemini for further query. So moving ahead, next step is basically the initialization of the LLM. So again, as we know, this is just a demonstration purpose. We have selected a free version of Gemini API, and we are setting up temperature zero point 0.2. So it ensures the factual and less creative responses. So this is what these parameters do. And at this point, the LLM object exists but has not been called yet. So moving ahead here, we have this prompt template. We are defining the prompt template. So this is a structured like a prompt which will guide Gemini on the role and task. So what is the role here? It is telling that you are a data analyst. And what is the task? Like answer the question, whatever being asked. It's a very simple role, right? And there are two placeholders here, data and question. So it will ensure that dynamic inputs at runtime. So still the execution has not started. We are just preparing like instructions. So here the next step is like this. You can see LLM chain. We are building the chain. So what does this line do? So this line is linking the prompt and the LLM. So, but we should remember the execution happens only when the run method is called. So at this stage, you can call in layman term that system is wired but idle. Moving ahead here, you can see here the run, like run method is called. So what is happening here? There is a user question variable which is containing the actual question, which product had the highest sales, right? So this question is defined, and data plus question is passed into prompt template. Now what is data here? Data is the summary data. If you remember, what was the summary data? So summary data is this n largest file, the top five sales, top five products, like, right? It is it is stored in the summary data, and from here both these things are sent, right, into this chain, and from the chain it goes to the prompt and it flows like that, right? And this prompt is rendered. Finally, it's sent to Gemini, and Gemini processes and returns the answer. So the point is that this is the place where the execution takes place. Otherwise, before this step, everything was initialized. Let's see this, how this output is working for both the scenario, and largest as well as and smallest. Let first set the few important things. Just a second. So these are few settings we need to do before running the code. Okay, now we are into the virtual environment. Now let's run this with the highest cells. So what we have done here, we have, like, it will print the things like question, it will print the summary data, and finally it will give the answer, right? So let's run it here. Okay, let's see. Okay, we can see here. Uh, so initially the generated sales data is here, the entire 9 records, 10 records. Then there is a summary. Like, since we asked about what is the top selling product, right? So the summary is coming like the top five. It is giving not only the, this is a mid layer, intermediate layer, along with the smartphone, laptop, camera, monitor, and tablet. And finally, this summarized input goes to the LLM, and the result is coming like smartphone, because this is the highest sales. So here, this token efficiency has been taken care of, the summarized data. Now let's change it and see how it works with when we change the prompt to question to the list, right? List cells. So here we have already made the question. We'll just uncomment it and comment the another line, which is the highest cells. And accordingly, we have to set the summary data also. Here we are calling the n smallest. Okay, let's run it now. Okay, let's see the result. So you can see the summarized data contains the bottom five, which includes mouse, keyboard, smartwatch, headphones, printer, and the answer is, as expected, is mouse, right? So this is complete demonstration for this particular part. So now I can ask all of you that why this matters for data engineering plus Gen AI, this particular demonstration, right? So answer is very simple, that this workflow is showcasing a very important pattern in data engineering with Gen AI. So before sending the raw data to a model, we have pre-processed and summarized the data, right? So this is making the solution both cost efficient and scalable. So the use of n largest and n smallest here acts as a pre-filtering step, which ensures that only most relevant slice of data is handed to the LLM. In larger pipelines, this becomes crucial before implementing the RAG structure, pipeline, right? The retrieval augmented generation. So think of this as a preparatory layer, the preparatory layer. We first summarize and structure, then move into more advanced RAG based pipelines where external knowledge bases are integrated, right? That's it. And like we also saw here how this LangChain and Gemini can be combined for token efficient analysis of structured data. We touched upon the importance of pre-processing steps like n largest and n smallest for controlling data scope. So in the next step, what we will do, we will extend this concept into retrieval augmented generation pipeline, RAG pipeline, so making the pipeline more robust and knowledge driven. So see you in the next video. Thank you.